Hi guys. Okay, so let's look at the functional groups in organic chemistry. These functional groups are the active sites where the reaction occurs. Now, R is represented as rest of the molecules which does not take part in the chemical reaction, whereas the site where the bonds are broken and the new bonds are formed or the exchange of the electrons occurs, that is known as the functional group site. Now, organic chemistry, there are many functional groups, and when we name them in an order of priority. So what you see here is a list of the functional groups in the order of priority from high to low. For example, if in a molecule there are two or more functional groups, then you need to follow this order in order to name them. So how do we do this? First of all, I'm going to write down, and I could easily give you a handout, and you can in the handout, you can easily, remember them or look at them. But when you actually write them with your own handwriting, right, you can see the connectivity and then you can remember more. So first of all, R, as I said, is the rest of the molecule. Doesn't matter what it is. The main thing that you see, the number one, is the acidic group. The acidic group is also, normally we write it as RCOOH. Okay, commonly it is written like this, but I've shown you the structural formula of the carboxylic group. And the name is, this is the carboxylic acid, or this is the carboxylic group. Carboxylic group. Okay, so example like acetic acid, benzoic acid, these guys have this type of group, the COOH group. Okay, next is there is also, instead of carbon, sulfur can be replaced, and that becomes a sulfonic group. Okay, so then it becomes a sulfonic acid. So we call this like sulfonic group. Okay, so instead of writing group again and again, I'm going to just not, so you get the idea. So these are all groups. Okay, next, now the third priority is the anhydride. Okay, now what is anhydride? When two acids fuse together. So here R can be the same or R can be different, it doesn't matter. So here you're going to form the same acidic group, COO. Now here, instead of hydrogen comes the carbonyl of the other acid, CO, and then R. R could be the same, R could be different, but it is this group where oxygen is linking the two carbonyls. This is called the anhydride. Anhydride. So basically, water, is removed. So this is the anhydride group. Next comes the ester, right? So anhydride, if there is a competition, we would still have the same, we would follow first the acidic and then the anhydride group. Okay. Next comes the ester. Okay, ester. Ester is, ester looks like this. So again, one acid, the carbonyl group of one, and here comes the oxygen and R. So instead of another carbonyl, it's just an ether linkage, oxygen linkage, okay? And so this is the ester. Next is the, number 5 is the halide. Halide is it could be chlorine, bromine, so, but commonly it's chlorine. So R, CO, and Cl. Okay, so this becomes the acid halide. Acid halide. Acid halide. Halide, and you can add, if it's chlorine, then it becomes chloride. So I'm going to just put X here. So X, and X stands for halogen. All right, next is 6 is amide. Okay, amide is R, CO, NH2, right? NH and NH and then R. So it could be, okay, it depends. There are primary, secondary, and tertiary, and we'll study those. So here, H and R and 2. It could be one hydrogen and one alkyl group or R group. or two R groups. So that would be still the name. This is the name. The functional group is amide. Okay, there are primary, secondary, and tertiary amides. So that's what it means. So let me put this here: primary amide, secondary amide, and tertiary amide. Okay. Next is, after that comes after the amide is the nitrile, and the nitrile is R, C, and triple bond. So it's the nitrogen. So this is the nitrile group, N-I-T-R-I-L-E. Okay, so it's a good idea that you write with me. Okay, after that comes the aldehyde, and aldehyde looks like R, C, O, and H. So you see, instead of OH, now it's just H. So this is the aldehyde, A-L-D-E-H-Y-D-E, aldehyde. Okay, then comes the ketone, that is R, carbonyl group, R dash, and this is the ketone group, ketone. Okay, all right. Next is the 10th. That is the alcohol, and the alcohol is R, O, H, and that is the OH group, alcohol. The OH group here is the alcohol. This is different from the NaOH group, okay? Then comes the thiol. Then 11 is R. Instead of oxygen, we replace it with sulfur, and this becomes thiol, T-H-O-L, thiol, okay? After that comes the amines, and the amines are R, R dash, any number, N, and again, there are primary, secondary, tertiary amines. So here also in the alcohol, okay. Yeah, so this is the primary amine, secondary amine, and tertiary amine, okay? So we will discuss this more later, but let's finish this. So here, after that comes the last is the ether linkage. After that is the ether linkage, which is R dash O R dash, right? Is the alkoxy. So this is the ether, and it's the same as the thioethers. So so oxygen can also be replaced with sulfur. So R dash sulfur and R. So this is the so that's the amine. This is ether, and this one is the thioether. These are called thio, T-H-I-O, ether, E-T-H-E-R, ether. Okay. Now after that are the enes. Enes are going to come before the ines. So in other words, anywhere you have the double bond, it's going to take priority over the triple bond. So for example, you have R, C, H, double bond, C, and then let's say you have R and then some other group, R dash. So it doesn't matter, you know, the triple bond. So this is some group, and it has this number, this will, if there are double and triple bonds in a molecule, then R, C, triple bond, C, R dash. So the triple bond will have a lower priority in numbering. So we actually call it ene comes before ine. Ene comes before ine when we name them, okay? Naming. Next is the functional groups that are always prefixes. Now, here's the thing about them. There's something that we did not discuss. We just named them in the order of priority, is about prefix and the suffix, okay? Now, prefix, let me use a different color here. Prefix, let's do this thing here. So the prefix is blue color. Okay, and let's do the, so prefix is the blue color. Okay, so this, if this is a prefix, is carboxy. Carboxy. So that's prefix is if we are naming them. So that would be carboxy. Okay, in naming, prefix comes first. So carboxy. Then this would be sulfo, right? This is going to be sulfo. Anhydride will remain anhydride. Now, alkoxycarbonyl. This one is alkoxy. Alkoxy, the OR is the alkoxy, and carbonyl is the carbonyl, the C double bond O. So this, the prefix is alkoxy, carbonyl. So again, this is for naming, okay? Next is the acid halide becomes whatever it is, chlorocarbonyl or whatever, then this becomes the halocarbonyl. So halo means it, if it is chlorine, bromine, iodine, so it's bromocarbonyl and so forth. Amide becomes aminocarbonyl. Okay, amide. And then the nitrile becomes the cyano. So again, when you're naming them, then you will see them, but these are all going to be prefixes. Now, aldehyde is formyl. Okay, and then the ketones are the oxo. This is the, again, in prefix, that's going to be oxo, O-X-O, oxo, okay. Alcohol is hydroxy. So prefix, hydroxy. So right now, just write these. When you name them, then you know if it's the naming hydroxy, O-X-Y. Okay, then comes the thiol. Thiols are mercapto, M-E-R-C-A-P-T-O, mercapto. Okay, then comes the amine, becomes amino, A-M-I-N-O, amino, right? Then the ethers are oxy, O-X-Y. All right, then comes the enes and the ines. These are just, ene. This would be labeled as ene, and this would be labeled as ine. So these were the prefixes, but there are also suffix. Suffix in naming is the one that comes later. So let's get another color for this. Let's get this color. Okay, now that's suffix. So S-U-F-F-I-X. Okay, suffix is the end, the ending. Okay, prefix. So suffix is for the carboxylic, it ends in oic acid. Okay, oic acid. Like benzoic acid, like that. Oic acid. Okay. Sulfonic acid, right? Anhydride will be anhydride. Ester is going to end in 8. Ester ends in 8. And that is, one second, let me just remove this guy. So ester is ending in O8, like benzoate, O8. Okay. Next is the halides. The halocarbonyl ending is going to be oil halide, like benzoyl chloride. Okay, oil halide. This is too big. Okay, oil halide, OYL halide. Okay, next is the these amines, the amines, the aminocarbonyl, and then the ending is going to be in amide, A-M-I-D-E. Prefix, the suffix, sorry. Then the one that was in cyano, the ending will be in nitrile. Okay, then the aldehyde, right? Then the ending is al, right? Benzaldehyde, right? That. Then comes ketone. So this is one, O-N-E, ketone. Okay, then comes the alcohols, and the alcohols are like methanol, right? Ethanol. So the ending is OL. Okay, then comes the SH. So this is just thiol. Then comes the amines, right? Amines will all end in amine, like methylamine, ethylamine, like that. Okay, then the ethers, the same as, so that this is ethers. Ethers will be oxy. Ethers, I think ethers will just be ethers, like diethyl ether, right? Like that. Thioethers will also be just like thioether. Okay, and then once we start naming them, you will see them. Okay, then comes the ene, and the ine is the same, like ethene, ethyne, acetylene, right? Like that. Okay, so these are the priorities. Now these are related to the functional groups which have a priority, but there are some others also which very active. So let's look at these ones. These will always be prefixes, and these will, when you're naming them, let's see these ones. Okay, so these functional groups, let me put this here, functional groups that are always prefixes, like they can never come in the end. Okay, always prefixes. And which ones are those prefixes? Always prefixes are these. So, and they are ordered when we are naming them. So we name them in the order of alphabetical order. Okay, so the naming is in the alphabetical. So their order is alphabetical. A, L, P, H, A, B, E, T, I, C, A-L. Okay, so like for example, bromine, chlorine, fluorine. So bromine comes first, then chlorine, and then comes fluorine. So alphabetical order, okay, for their naming. So all this relates to naming and the priority, and then of course the introduction to the functional groups. All right, now let's look at these guys here. So once again, so here we have the groups. Okay, and so then their prefixes are I'll write that later. Okay, otherwise it gets too cluttered. Okay, number one. Okay, here is, for example, R, rest of the molecule, Br. Okay, then so these are the halogenated, so they are halogens, right? They are all halogenated groups. So RBr, second comes the RCl, and then comes the 3 is the RF, and then the last one is the iodine. So this is their order. Okay, R, I. So what are their names now? The names is, this would be named as bromo, and then whatever it is, like bromo, cresol, and so forth. So this is the prefix for these. One second. Prefix. And their name, right? So prefix and names and group names and prefixes, bromo. Same thing, bromo. Then comes the other one is, chloro. Then comes fluoro. And then comes iodo. Okay, so that's one thing. Next after that comes the like the ethers. Like I said, the ethers will just remain ether. So the ether, the priority, okay, oxygen, and then R dash. Okay, here these guys, the ether is ether, and this is also called alkoxy. ALKOXY. So methoxy, right? So prefix is that. So here prefix is also bromo, chloro, fluoro, and iodo. Then alkoxy, like methoxy, methyl, or dimethyl, or a diethyl ether. So alkoxy alkanes, coming from there. Okay. Next is the azido. All right. Next is the azido. Number 6 is azido, and azido is with 3 nitrogens. Okay. Azido is R, N, 3 nitrogens. So 3 nitrogens together. Okay. That makes the azido group. And so the next after that is the nitro group, R, N, O, 2. That is the nitro group. And what is the prefix for these guys? The prefix in this one is azido and nitro. Nitro. Okay. Now, these are the main ones. Then we will discuss other, other priorities also regarding the aromatics. So I think we should look at these also. So as we know, let's look at the aromatics. Also here is 1 second. Okay, and we also have the, we already discussed the alkane, alkene, alkynes, and then the aromatics. Okay, so let me move this here. So alkene, alkenes, and alkynes. Okay, so we know that the alkanes, we discussed that one earlier in the previous videos. Alkanes, carbon-carbon single bond. Alkenes, unsaturated. So these are carbon-carbon double bond. Alkynes, triple bond. Okay, but aromatics are the ones that are ringed, but unsaturated. So here are those rings, the unsaturated. Okay, and then there is substitution on these rings also, right? So mono substituted, di substituted, tri substituted. So there is also naming criteria for that. So let's look at the order of priority here also, just so you have them. So here is the common mono substituted in that. So common mono substituted benzenes. So what is the order of priority here? Okay, so here let's look at the number 1 is the methyl, then the I think I'm doing this right. Yeah, so here is the toluene. Let's look at there. So here is toluene, methyl, okay? And so this becomes the methylbenzene, okay? Methyl, this is the common name is toluene, This is commonly called toluene, but the other name is the methylbenzene, methylbenzene, okay? So this is the benzene group or benzene, structure. And so if there is a substitution of a methyl group, then it becomes methylbenzene. On the other hand, if there is a substitution of OH, then it becomes phenol, okay? So this is also shown, it can also be shown as like this, okay? So this becomes phenol, phenol. Okay, common name is phenol. And we will write down the other one. Benzonol. I'm going to write down the other one later. Let's do this one. This is the alkoxy. Alkoxy. So here, so this is the methoxybenzene, right? Methyl group with the oxygen and then the benzene. So this becomes methoxybenzene. The common name of this is anisole. Okay, anisole. And then comes the benzene with, so these monosubstitute, if there is a disubstitution, you should always look at when you're naming the monosubstituted. Okay, you should look at the like which one is it? It's the phenol, and then look at the substitution. If it's an amine, then this is the amine, and this is called aniline. Its a common name is aniline. Okay, now let's cover these names, other names. So the first one, this is also called benzanol. Benzanol, benzenol. All, OH is the all. The other one is the methoxy, or it can also be ethoxy, or, you know, oxy group is the oxygen with the alkane. So this is methoxybenzene. Okay, then comes aniline, and that is benzenamine. Benzene, amine, AMINE. Okay, then there is other ones which are right here is the styrene. Okay, styrene is here, and then like a double bond right here, like that. So this is styrene, STYRENE, and the actual name is ethinyl benzene. Ethinyl benzene. Okay. Sorry. Ethinyl benzene is ETHENYL benzene. Okay, so look at that. These are the main structures, like the main monosubstituted benzene. And then whatever the other substitution is, then it goes after that. So this is the parent, actually. So these common monosubstituted benzene, these act as parents, a parent. And then whatever other substitution is that's put on it, and that gets that name. But the parent will get the name first. First, find the parent in a mono and disubstituted benzene, and then the monosubstituted, and then you name them. Okay, next is, let's look at the other piece, which is the benzaldehyde. Okay, so common one. So here is the ring, okay, and here is the carbon, aldehyde group, oxygen, and hydrogen. Okay, so this is the aldehyde group. So this becomes benzaldehyde. Benzaldehyde. Okay, benzaldehyde. And this benzaldehyde is benzene carbaldehyde. It's the other name. Okay, next comes the COOH. Okay, that's the acidic group. So this is the benzoic acid. Okay, the acidic group. So with the benzene, benzoic acid, and then whatever other substitution is, that goes there. Okay, but other names are, the benzaldehyde is also called benzene carbaldehyde. Benzene carbaldehyde. Okay, and then benzoic acid. So you remember there's an IUPAC naming. So benzoic acid is the benzene carboxylic acid. Benzene carboxylic acid. Okay. Next is the benzene, and then you have the oxygen, and then you have Cl here. Okay, so carbonyl with a halocarbonyl. Okay, so this becomes benzoyl chloride. This is benzoyl. The parent is benzoyl chloride. And if you have to substitute it, you know, whatever, you write down the benzoyl chloride and then the substitution. So this becomes benzene carbonyl chloride. Benzene carbonyl chloride. See, organic chemistry, you should just do it and not just see. It's not just seeing. When you do it, you understand the connectivity and like you understand the formulas. You can write the formula. You have to write it, okay? So here is this oxygen, carbon, and then oxygen, and then here. So this is the ester. Remember the ester group. So this is methyl benzoate. Methyl, because you have methyl group there, it can be ethyl, it could be isopropyl, any benzene, butane, any group. Methyl benzoate, B-E-N-Z-O-A-T-E, methyl benzoate, okay? Then comes the amide. Here, benzene, oxygen, and NH2. So this is the benzamide, B-E-N-Z-A-M-I-D-E. Okay, benzamide. Then comes the last one, which is here, carbonyl group, and then methyl. So this is the acetophenone, acetophenone, A-C-E-T-O-P-H-E-N-O-N-E. Remember that, on from the ketone, okay? So this also means 1-phenyl. For the IUPAC naming, 1-ethanol. Okay, 1-phenyl, 1-ethanol. So acetophenone. So in this case, it's not, the main is not the benzene, but ethyl, you know, this ethanol, you know, that site is given priority. But anyway, so that is the functional groups with the nomenclature, okay, with the naming and then the priority, okay. All right, so this finishes this. And we're going to now look in the next video about the nomenclature also and the namings, okay, and then formulas and other things. All right. Okay. Thank you so much. Thanks for watching.